The diagram shows the graph of y equals x minus 7. Write the coordinates of one point on the line between A and B. So we can see that between A and B, the y coordinate will need to be negative because the y coordinate we can see is less than 0. And then the x coordinate we can see will need to be less than 7 because point A has an x coordinate of 7. So if we have x as 1, 1 minus 7 is minus 6. So if the x coordinate is 1, the y coordinate will be minus 6. We could also have 2 and minus 5, because if x is 2, and remember we write the x coordinate first, if x is 2, 2 minus 7 is minus 5, so that will be the y coordinate. We could also have 3 minus 4, 4 minus 3, 5 minus 2, or 6 minus 1. This graph shows the temperature in a greenhouse. Use the graph to find the time when the temperature was 25 degrees. So 25 degrees will be right in the middle of 20 degrees and 30 degrees. So that's this line here. If we draw a line across, we can then draw a line straight down from where it hits the line on our line graph. So we need to work out what this time here is. We can see that we have our hours marked. So these lines between the hours will be half hours. So half an hour is 30 minutes. So that means this point here is between 3 o'clock and 3:30. So I would estimate 3:15. Now use the graph to find the difference between the temperature at 2 p.m. and the temperature at 4 p.m. So we can find 2 p.m., draw a line up, and then we can see that the temperature at 2 p.m. was 20 degrees. Now if we find 4 p.m., we can go up and across, and we can see that that's between 30 and 35. But it's closer to 35 than it is to 30. So I would estimate that that's about 33 degrees. So we need to find the difference, which means we need to subtract, and 33 minus 20 is 13. So the temperature increased by 13 degrees. You also get the mark for an answer of 14 degrees. So you could estimate that this point here is at 34. The pie chart shows the year groups of children at Woodland Infant School. There are 56 children in year 1. How many children are there in reception? So we can see that there are 35% of the children in year 1, and that's 56 children. 45% of the children are in year 2, but we're not told the percentage that are in reception. But we can work it out because we know that percentages need to add up to 100%. So if we know that there are 45% in year 2 and 35% in year 1, that's 80% altogether. And if we subtract that from 100, that tells us that 20% of the children are in reception. So we know that 35% are in year 1, and that's 56 children. So we can write 35% equals 56. But we want to know 20%. So how can we get 20% from 35%? Well, what we can do is first work out 5% by dividing 35 by 7, and then we can find 20% because 5 times 4 is 20. So 35 divided by 7 is 5, so if we do the same to the total, 56 divided by 7 is 8. So if 5% represents 8 children, to find 20% we can multiply by 4. 5 times 4 is 20, and 8 times 4 is 32. So that means there are 32 children in reception because 20% of the total must be 32. Here is a cube. The top half of the cube has been shaded all the way round. Here is the net for the cube. One square has been shaded for you. Shade more of the net so that it could fold to make the cube above. So first, let's think which faces are shaded on this cube. We have a whole face shaded here, and then we'll have a whole face shaded on the other side as well. We have half a face shaded at the front, and we'll have half a face shaded at the back. So let's imagine that this shaded face is the shaded face round this side that we can't see. That means to shade this face, we can shade this face here on our net, and then we can shade a triangle on this face because that's the triangle at the front. So this edge will fold around to meet this edge, which means we need to shade this part here. And we also need to shade this triangle or this half square here, because this edge will fold to meet this edge, and that will be the face that's round the back. Here are the ingredients for fish pie for 2 people. Omar makes fish pie for 3 people. How many grams of fish should he use? So if we know the total amount for 2 people, so we know that 2 people needs 250 grams of fish, how can we work out how many grams of fish we need for 3 people? Well, what we can do is work out the amount of fish that we would need for 1 person, and we can do that by dividing by 2. 2 divided by 2 is 1, so if we divide 250 by 2, that tells us that we need 125 grams for 1 person. So then, to find the amount needed for 3 people, we could either add the amount needed for 2 people and the amount needed for 1 person, because that's 3 people altogether, or we could take the amount needed by 1 person and multiply by 3. So 125 times 3 is 375. So he should use 375 grams. The triangle and rectangle below have the same area. Work out the value of W. So we need to work out the width of the rectangle. Now we can find the area of the triangle, because to find the area of a triangle, we multiply the base by the height and then divide by 2. So 4 times 6 is 24, divided by 2 is 12. So the triangle has an area of 12 centimetres squared. And we know that the rectangle has the same area. So to find the area of a rectangle, we multiply the length and width. And we know that the area is the same, so the area will be 12 centimetres squared as well. So what times 4 is 12? Well, 3 times 4 is 12, so that means the width must be 3 centimetres. So W is 3. Lili and Julian each start with the same number. Lili works out half of the number. Julian works out 3/4 of the number. The sum of their answers is 275. What was the number they started with? So Lili has found 1/2 and Julian has found 3/4, and they've added their answers. So we can work out 1/2 plus 3/4 to find the total fraction of the number that they found. 1/2 is the same as 2/4, and if we add 3/4 to that, we can see that they found 5/4 of the number. So that means 5/4 of the number is 275. So normally, to find a fraction of a number, we divide denominator times top. But here, Because we have a missing number problem, we need to do the opposite. So we can divide 275 by the numerator, so divide by 5, and that gives us 55. Then we can multiply by the denominator, and 55 times 4 is 220. So that means they started with the number 220. Amit has some small cubes. The edge of each cube is 1.5 centimetres. He makes a larger cube out of the small cubes. The volume of this larger cube is 216 centimetres cubed. How many small cubes does he use? Well, first of all, let's find the dimensions of the larger cube. So we need to think what times what is 216. Now, because it's a cube, not a cuboid, all of these numbers will be the same. So let's use trial and error. If we try 5 times 5 times 5, 5 times 5 is 25, times 5 is 125. But we want 216, so we need to try something larger. 10 times 10 times 10 is 1000, but that's a lot more than 216. So let's try 6 times 6 times 6. 6 times 6 is 36, and then 36 times 6 is 216. So that means his larger cube has side lengths or edges of 6 centimetres. So how many 1.5 centimetre cubes do you need to make an edge of 6 centimetres? Well, 6 divided by 1.5 is 4, because 4 times 1.5 is 6. 1.5 plus 1.5 is 3, plus another 1.5 is 4.5, plus another 1.5 is 6. So that means each edge is made up of 4 cubes. So Amit has a cube like this. He's used 4 of these 1.5 centimetre cubes on each edge, because 1.5 plus 1.5 plus 1.5 plus 1.5 is 6, and we know that the edges of the cube must be 6 centimetres. So how many small cubes are in this cube here? Well, to work that out, we need to multiply 4 by 4 by 4. 4 times 4 is 16, times 4 is 64. So he uses 64 cubes.